And I was going to show you how to graph this in Desmos, but Desmos does not just graph polar coordinates like this. You can graph polar equations, which we'll get to later. Alright, now some of these things should look very familiar. To convert between polar and Cartesian coordinates, we're going to use some relationships that we're already familiar with. So we've seen this before where we know that the cosine of theta is equal to x over r, or that x is equal to r times the cosine of theta. We've seen that sine is equal to y over r, or that y is equal to r sine of theta. And we've used this for the circle before, where x squared plus y squared is equal to r squared. So we're also going to use the tangent of theta being y over x. And if you look at your reference sheet, these are all on there with your unit circle. Alright. So that's the good news. Those aren't anything new. We've used some of these before. So let's just convert some of these. Alright. So here r is equal to 7. Theta is 7 pi over 6. And we can go ahead and get our equation set up. So x is equal to r cosine theta. Y is equal to r sine theta. And we just plug these in. So we get 7 cosine 7 pi over 6 and 7 sine 7 pi over 6. And we know what that is from the unit circle. So the cosine of 7 pi over 6 is negative square root of 3 over 2. And the sine of 7 pi over 6 is negative 1/2. And that gives us an answer for part A of negative 7 square root of 3 over 2, comma, our y value would be negative 7 over 2. Alright, so for part B, we're doing the same thing, except x is going to equal 6 cosine of negative pi over 4, and y equals 6 sine of negative pi over 4. So again, we use our unit circle and realize that negative pi over 4 is the same thing as 7 pi over 4. We get 6, and we get the square root of 3 over 2 for the cosine, and we get negative 1/2 for the sine. So that gives us an x-coordinate of 6 divided by 2, which is 3 square root of 3. And then 6 times negative 1/2 is negative 3. And then for part C, we're doing the same exact thing, so except we're using pi over 6 and negative 3. So the cosine of pi over 6 is square root of 3 over 2. And the sine of pi over 6 is 1/2. And that gives me my final answer of negative 3 square root of 3 over 2 for my x-coordinate. And my y-coordinate would be negative 3 over 2. And sometimes we have to go the other way. So in this case, we have to go the other way. Now, 4, 2, this is first quadrant. 3, negative 5 is in the fourth quadrant. Okay, we'll use that information as we go. So we got to remember a couple things. We need to know the radius and we need to know theta. So it doesn't matter where you start, you're going to use both of these equations. Since we already know the x and the y, let's use the tangent of theta being y over x to help us figure out the angle. And then we need to know the radius. Well, we know that the radius squared is just r squared is x squared plus y squared. So we can plug in x and y to these and figure this out. So tangent of theta is equal to 2 over 4. And then theta is equal to the inverse tangent of 2 over 4, or 1/2. And that gives us theta being 0.4635, roughly, if you round. And then r is going to be 4 squared plus 2 squared. So that gives me 16 plus 4, which is 20. So r is equal to the square root of 20. And if you remember right, you can pull 4 out of that. Square root of 4 is 2. Square root of 5. So if we were to write this as a coordinate, we would do 2 square root of 5, comma, 0.46365. All right. Same thing here with the tangent. Now, this one's going to be a little different. We're going to get the tangent of theta equal to negative 5 over 3, because we're using y over x. And if I do that inverse tangent of that, I get a negative number. Now, we could keep that negative number, or since we know it's in the fourth quadrant, we could add 2 pi and get our angle in radians in the fourth quadrant. So either way is fine. I would say let's use this one since it's a positive number. And then r squared is going to equal 3 squared plus negative 5 squared. So that's 9 plus 25, which is 34. And the radius is equal to the square root of 34. So our final answer is square root of 34, comma, 5.252 as a polar coordinate. Sometimes we also have to convert to a polar equation. There's going to be times when doing a polar equation is going to be a lot easier than having Cartesian coordinates. So we've got this. Now we just need to remember that x equals r cosine of theta. It's one of our ways to convert. So since that's the case, we know what x is. So 3 equals r cosine theta. And we're going to solve this for r. So most of our polar equations are going to start with r equals something. So in terms of theta. So I'm just going to divide both sides by the cosine of theta here. And 3 over the cosine of theta is the same thing as 3 secant theta. And that equals r. Or we could technically rewrite it better by putting r first. R equals secant 3 secant theta. That's our final answer. And next time I'll show you how to graph these with Desmos. And you'll see that that's the same line as x equals 3 on a Cartesian plane. So here we've got y equals 4x squared. We're going to have to remember a couple things. Y is equal to r sine theta, and x equals r cosine theta. If we use those, we can simplify this down and get our final answer. Okay? So I'm just going to replace y with r sine theta. And I'm going to replace x with r cosine theta. And then we're going to do some solving. Alright, so r sine theta equals 4, and that's going to be r squared cosine squared of theta. Now, we can get rid of the r. We can divide an r out of both sides. It won't matter in this case. If we were solving a regular equation, those kinds of things do matter, but in this case, it's not going to matter because if r is 0, we don't have anything. So I've got sine of theta equals 4r cosine theta, and now I'm going to get r by itself by dividing this by 4 cosine theta on both sides. It's actually cosine squared, my bad. 4 cosine squared theta. And that leaves me r on this side. And now you can write this a couple ways. I'm going to go ahead and write 1/4 out front because the 4 is on the bottom of the fraction, so that's just the same thing as multiplying by 1/4. Sine divided by cosine is tangent. So let me rewrite that out as it's sine of theta over cosine theta times 1 over cosine theta. and then that's just 1/4 tangent theta for the sine over cosine, and the 1 over cosine is the secant theta. So r equal to that is my final answer. Again, they all have some similarities. If you've got x squared plus y squared, you should know that r squared equals x squared plus y squared, and y equals r times the sine of theta. And then we just substitute these things in. So this is just r squared 4 times this r sine theta. Now again, I've got an r on both sides. It's not going to be much of an equation when r is equal to 0, so we can get rid of that. If I divide both sides by r, I get r equals 4 sine theta. Alright, so again, I'll show you some more next time with using Desmos. I wish it would plot the regular polar coordinates like we had at the beginning, but that's just going to be something you're going to have to do by hand. And then eventually we'll graph this equation on Desmos, and I'll show you that these two equations are the same next time. Alright, so on the first few problems, I do want you to plot the points as well. It helps you to convert from polar to Cartesian, and on 2 through 10, I want you to go ahead and plot those. So I've got graph paper for you for those.